So our assignment is how does water and carbonate affect the geochemistry of the subduction zone and the boundary picture figure. First, we have to know some backgrounds. That new form oceanic ocean crust comes from the ocean ridge are almost without water and volatiles. And mostly made up with plagioclase, olivine, and pyroxene. They are without water. They are dry mineral. This is their uh, and the other volatile were also removed from the mantle while the mantle melted. And there are some doubts that this in observation we notice the percentage of water and volatile in oceanic crust are high as subduction zones. Like the table 12.2, we see uh, this is mantle, this is ocean crust, and this is the sediment above ocean crust during the subduction zones. You can see here is containing CO2, H2O, and other material. And you can see in the outer ocean crust and the sediment, it have a higher abundance in them. And so why is it higher? First, about the water is that hydrothermal interaction with the water alter the rocks, generate some hydros. Hydros means you have water in it. Hydros minerals like amphibolite, serpentine. This is amphibolite and serpentine. This is peridotite. Okay. Then second, sediments on the crust. The sediment will drop on those crusts from many places like river, wind, or even the dead body. And most of land have high percentage of water content. And third, the high temperature and high pressure let the carbonate and silicate react and release the CO2. And about other, high percentage of water content material will take up other elements like this with them. Okay, so I will see this picture. Okay, so that's sediment we just told, and the outer mantle. It's from the peridotite to serpentite. I don't know. Serpentinite, and it will becoming having more H2O in it. Okay. So water and volatile get into mantle. What is it about? It's the volcanoes will be created. As we know, the volcanoes that form along with subduction zone is quite common. Like this. Okay. When the mantle upwells, the decreasing pressure will make it melt, like what we told last week. Yeah. And in contrast, in subduction zone, the increasing pressure will make the crust not melt, or we can say freeze. But that's not true since we know the volcanoes are there. So why? The answer is water and the volatiles. Let's see this picture. It's the x-axis is the percentage of water content, and the y-axis is the temperature. When you have high percentage of H2O, high percentage of water, you will get a depressed freezing point, which means the melting are easier. But this is only happen in high temperature condition, because high temperature can let the metal dissolve more water in it. Okay, so therefore the magma containing water and upwell to surface and form the explosive arc volcanoes. Yes, that's all.
Okay. Okay, group student. Questions, comments? Rich? Rich, you have a question? But you have to shout because we don't have the wireless microphone. You tell me your question and I repeat again. What's your question? What's your question?
So what's the main effect of carbonate?
What's the main effect of carbonate? Okay, Andy. What is the main effect of carbonate?
That's a good question. Actually, I don't quite understand. Maybe it will help the water go into the conduction zone. I don't know.
You don't know. Rich, do you have your own answer or you just ask this question?
I think
You think?
maybe it has some it may let the sediments react to become the part of the subduction step.
It help it react with the sediment.
Yes, it can react to another form
Uh-huh.
and become the part of the subduction.
Slab.
Yes. From the crust to enter the subduction.
Okay, Rich said CO2 will react with the subducting material and and become part of the slab. That's what you meant.
I say carbonate.
Carbonate.
Yes.
Okay. Well, that's partly true. We can talk more about it later during my lecture. Group A student? A student? Question? Any? Moment. Sally? You don't have a question. Kevin? Kevin is not here. Ian? Ian is not here. Tell us.
The table. The table. Just, can you explain why over a pentanite, why the water content and the carbonate content is higher than primitive metal?
Bella's question is, this is serpentinite. Okay, serpentinite. She asked, why is the water content in altered serpentinite higher than primitive metal, right?
Yes.
Hmm.
Mm.
Hmm.
Mm.
That's because the high temperature and high pressure, yeah, that will react and make the carbonate and silicate decomposition and release CO2 and like water. Yeah.
All right, apparently there's no clear logic in your answer. But I think serpentinite is the topic of Group B student. So maybe I can ask the Group B student if she has a good answer. B student. B student? No? Volunteer. Zhiyi.
Okay.
Can you repeat the question again? The question is, you see on the table, primitive metal versus altered serpentinite. And this material has much higher water content than primitive metal. Why?
Because serpentinite was formed with water, so water abundance have higher.
Well, it's a very simple but correct answer. Because by definition, serpentinite is the product of water-rock interaction. So it's formed by water. And mantle, as mentioned in Andy's talk, mantle itself is very dry. So the mineral is very dry. So the water content is low. I need to ask another A student. Jackie?
Again, why the freezing point in pressure will get lower when the hydrate become more. And explain again the curve.
Can you explain again this curve?
Okay, it's when you have higher water percentage, that will increase. No. That will decrease the freezing point. But how? I don't know how.
Okay, you don't know that. I don't know either.
Well, if you ask what's the explanation for this feature at the atomic level, I can tell you I don't know either. But this is, I think there must be some experimental proof. For example, some geologists took some rock and add some water at high pressure and temperature, and with higher water content, the mantle dry the solidus. This is actually solidus. The solidus will decrease with increasing water water percentage. So
So it's just a phenomenon and cannot be explained.
I think there should be some atomic level explanation, but I don't know, and it's not mentioned in the textbook because I'm not a petrologist, 就是不是岩石学家, so I cannot tell you the detail. But what's more important is this feature explains why magma can be formed at the subduction zone. Because based on our lecture 3 or 4 weeks ago, I have told you that rock melts only when it rises, when it depressurize, 就是解压才会有熔融，加压不会有熔融。But this is not what we see at the subduction zone. So this is a little bit like a counterintuitive, 就是又再次的反你的直觉，违反你的直觉。And this provides an explanation why this can happen. So that's the point. But I cannot tell you the atomic level explanation. But it's a good question. Okay, and no, I have a question for you. Can you go to the slides where you show the minerals? You have this photo, maybe serpentine. Alright, show the photo. Okay, you told us that these minerals, they are hydrous or hydrated or whatever. Do you mean you can squeeze water out of the rock? What do you mean by hydrous? Uh,
水河的感觉。
Okay, what do you mean by 水河? Hydration. What does that mean? You should learn that during your general chemistry. What does that mean?
It's like and
If you don't know the English, you can say in Chinese.
我还是不太会，才能。
What is 含水矿物明确的讲什么意思？水可以挤出来吗？
不行，它是它的结构里面会有爬一个水分子在里面，然后
Crystal water. So it's in the mineral crystals. It's not like you can squeeze a mouth of a cloth and you can get some water. So it's in the crystal structure. Okay. Thank you, Andy.
Here.
Huh? Sure.
So what's the cost of melting and volcanism and conversion process?
Once again.
Cost of melting and volcanism or convergent margins.
What is the cause of volcanism at the convergent margins? Is it a question to me or him? Oh, what? Okay, I should repeat. What is the cause, the reason of volcanism at the convergent margin?
That is because the freezing point is now low because of water, and it make the mantle will have the chance to melt, and those magma will upwell to surface and form the volcanoes we see. Yeah.
No, actually, this reminds me, I have another question. Can you go to the table? The table where you have this percentage of water, etc. Right. Maybe it's like right. I think here somewhere you were saying you say something related to uranium, rubidium, and uranium. You say something about it, right? Okay. What do you mean by high percentage of water content material will take up other elements like these with them? What do you mean? Do they dissolve in water?
Eh, I don't think so, but it's like it will have more easier to结合 with them.
Combine.
Combine.
With what?
with the oh I give up.
A student. Answer. Do you have any idea why? Apparently, this does not mean it dissolves in water like this element dissolves in seawater. This is not the case. So what does it mean? Any? Okay. This phrase is not exact. What we really, or maybe the textbook, mean is these, especially this. I have mentioned this weeks ago. These elements are so-called magma-phile, 爱岩浆. And here, at the subduction zone, magma forms because of the presence of water. Therefore, because of water, magma forms, and because magma forms, these elements tend to enter magma because they are, especially these, they are large atom, so they like freedom. They like to be free, so they like to enter liquidized rock. That's the reason why this seems to be related to water, but actually the missing link here is magma. Okay, thank you, Annie. Next, Vincent.
Okay, so our assignment is what is serpentization and where to find it, what are mineral involved, and what are gases produced, and what is it relative to the origin of the life. First, the serpentization is the process that leads to the forming of the serpentinite, just like this. This is
So what's the Chinese of serpentinite?
Serpentine. Yeah. So this is a picture of serpentinite. And it is the rocks from metamorphic rocks derived from hydrous alternation of olivine-rich ultramatic rocks and consist mainly of the serpentine group materials. And to some physical and chemical change between these two types. This is the original main minerals of the mantle, and they go through this mineralization and become this. So the dense will decrease, and hydrous means they have a less water and become more water, and from weakly magnetic to strongly magnetic. And the next question is where to find it. And in fact, the serpentinization is just the hydrous alternation, which means the origin material and water they reaction. So the environment that it can happen is where the rocks can get in contact with seawater fluids. So they have many different places that we can find it. In around mid-ocean ridges, in the detachment fault, just like this, and the water can go here, and in transform faults, just like here, the water can go through the faults and contact with the rocks, and hello, and in rifted continental march, just like this, and in the ophiolite complex here, and this is a little different because this is I mentioned that once the rocks can contact with the water, the reaction can go. So in here there is no faults, but this one. This is the oceanic crust materials that go down and in the continental crust. So there are some materials that can go the spatialization, and they located in different places. It's not fault. And the last one is bending relative force. Is around the splash zone.
What is of your life in Chinese?
怎么说？I forget it. And so, what minerals involve the serpentinization? At first, before the serpentinization, the original material is the peridotite, and there are mainly olivine and also pyroxene and cyanophyllene. And after it, they becomes mostly the serpentine growth materials, like minerals, like this one and this one. And the simply function of the serpentinization is this. So you can see before the serpentinization, the main minerals is olivine, and they react with water, just like we mentioned it last group student. And before it, they produce this, like serpentine we mentioned, perovskite, magnetite, and hydrogen. And here, hydrogen is a little important. Hydrogen, because it is relative to our last question, the life. Because the hydrogen produced here in some environments, just like the hydrothermal vent, and they have a chemosynthetic microbial organisms. They can use this hydrogen and as a power to go their life reaction. 新陈代谢，我忘记怎么讲。Metabolism. And thus, these organisms can produce biomass, and this is just like a primary production. So it can build a food web. So life systems can be built. And besides this, when the early history of the Earth, this hydrogen produced by this reaction, it may have a chance to be transformed to the methane or other hydrocarbons, which means it produces a material to development life. And this is reference.
Okay. Big group student, do you have any comments or questions? Hank. Tell me your question first.
During the process of olive become serpentine, and why is that become magnetic? Because of what?
So during the transformation of olivine to serpentine, why is there magnetite and it's magnetic? Do you have a answer to that?
You mean why magnetite will appear? You mean why Why we have this one?
No, in the previous slide.
Previous.
Maintenance.
Oh, you mean this?
Okay.
I think the answer is just because this material will have a magnet. So before the spatialization, we can see the main material is just prototype and it's mainly polymer. So there's no magnet materials. But after it, we have this one and it have a.
Okay. I happen to tell you the answer already. Okay. B student. Ethan.
What is the condition to happen the synchronization? Is this a high temperature or high pressure?
Okay, what's the PT condition for serpentinization? Can we have this at room temperature?
I remember the temperature is higher than 室温. Room temperature is around. I remember it's around maybe 300 degree Celsius, and the pressure is higher than our environment. But I forget what is
Do you
pressure.
have something to add on?
No, okay. Yeah, indeed, that was my question. It's if you need high temperature, it's not like you can have this you can have a piece of olive oil, you add some water, and then you get this fancy reaction. No, this will not happen. B student. More question? A student. Fellas.
So, before I just asked why the serpentine has high water content. So is it just because the water go into the mantle part and this reaction happens? Let me ask again. So in the A assignment, we know mantle is waterfall, but in a serpentine, it has higher water content, so it is related to the water go through get into the mantle. Is that?
I think you mean in A assignment, you see the table, the difference in water content between primitive mantle and serpentinite. And I think your question is, this difference, can we say this is because of water going down and in touch with some mantle minerals and create this difference?
My understanding is that the material of this peridot before the spatialization. In fact, in theory, this material will only appear at upper mantle, so it will not contact with maybe the water, maybe atmosphere. And in the question where we can find serpentinization, I mentioned some position, some geological structures. And these structures makes the material which in theory in the upper mantle can go up and contact with the water, just like the faults or volcanoes. So you mean is the water go into the mantle? And I think maybe not. It because some materials of mantle and they have some certain structures that can be contact with the water, and the spatialization can go. So I won't say that the water go into the mantle. This is my understanding. Did I answer it?
Yes.
In general, I would say because water moves relatively easily, so it is true that water probably does not really enter the mantle, but it will enter deep into the deeper part of the oceanic crust where the proportion of peridotite might be higher. And there, this is a place where we can start to see serpentinization. Okay, thank you.